I'm just having a look at exercise 4.4, question 11b, where it's got graphed this line that goes through -3 on the real axis. And it's saying that we need to determine the subsets of the complex plane that make the following graphs. So we just need something in terms of z, or an equation in terms of z, to represent this line. Now, my first thought was, all right, well, it's always a real value of -3. So I would just write real value of z is equal to -3. And that would represent that line. That's my first impression. That's what I would have done for that. Because basically you're just saying, you know, show me all the values for z that have a real component of -3. Well, that's them, all of them. Now, the back of the book has something different. All right? So it has z plus 4 is equal to z plus 2. Okay? The distance of z4 plus 4 is equal to the distance of z plus 2. So there's a couple of different ways I could look at this. Okay? I could, for example, well, I did this originally. I just thought, well, what if I substituted in for z, x plus iy, and then looked at the distances and worked out the equation, and if I did all that working, I'd end up with an equation that's x is equal to -3. Okay? And I can try and explain why this is the case an easier way, I think. If I write this as z -4 is equal to z -2, okay? You know, this is a correct solution, but it's one of many correct solutions. And what I'm looking at here is if I have z take away some other value here in these brackets, it's basically saying the distance from some value z to -4 is equal to the distance of that same value of z to -2. Okay? When are those two situations equal to each other is what it's saying. Okay? So if I look at my values of z, these are my values of z all along here. Okay? And if I look at where -4 is, -4 is here, and if I look at where -2 is, -2 is here, for all of these different values of z on this line, the distance from -4 to that value on the line is the same as, is equal to, the distance of this z value to -2. Okay? In every single one of these situations on the line, that distance to that point z is equal to the distance from -2 to z. And that's what this means. That's what it's saying. It's saying what values for z, okay, exist such that the distance from z to -2, that's what all of this means, is equal to the distance of z to -4. Okay? Now, logically you could think, right, if I just step out one more, -5, and I put this at -1. I know it's not to scale, it's not great, the 2 should have been there. The same situation is going to be occurring if I step one back, or even if I went half back each way. Again, the distance to z would be the same as the distance there. So I could have also written it as z plus 5 is equal to z plus 1, which is the same as the distance of z to -5 is equal to the distance of z to -1. Okay, like that. Okay, we're saying what values of z exist for that situation. Well, all of the z values that exist all lie on this line. I hope that helps to explain it. Thanks, guys.